All right, everybody. This is the Kubernetes Workgroup Device Management meeting for March 18th. And I will show our agenda. We have a few things on the agenda today. Okay, looks like first up is Matcha.
Yeah, I'm here.
Oh, let me give you need to display screen. You need to,
I think it will be easier if you could indeed give me host, co-host or something. Appreciate. Thank you.
okay.
This guy.
Here.
So the link to what I'm going to present is in the notes as well. So if you want to carry with me, I think this is so. Maybe I'll present myself. My name is Maciej. I am part of the multi-network community. We are working on enabling multi-networking Kubernetes in semi-core, and basically what we kind of recently got guidance on is to see if we can define multi-network via DRA. And we did that. And what I want to do today is to show you what kind of we have in mind, kind of high level. This is not set in stone yet. And we'd like to hear some initial feedback from the DRA community on, are we on the right track? Is there something better we can do? Is there maybe something that we can change in DRA APIs to maybe fit in the kind of what we're trying to do here? I think that's the kind of overall gist I'm going to kind of get out of this. Can you see my slideshow? I think this is going to be better. Is that okay?
Yes.
Okay, so multi-network DRA, I want to go through a CUJ of what we are seeing, how that will work on. So the first thing is the installation to the cluster. This is something TBD from our side. This is me to kind of plug out more, but we assume in this presentation, I want to just assume that all the components are there. The DRA is kind of enabled. It should be by default, but then the multi-networking component is there as well, in whatever form and however it was defined and installed by the platform owner. It has as well the desired provider, the DRA driver that is compatible with the multi-network, and it provides as well device classes to kind of how you do want to kind of whatever the driver comes with, right? And basically, what do we want to do and present is introduce a new CRD, right? We want to kind of hide the DRA aspects from the multi-networking community or the users of multi-network. At least that's the current kind of thinking we want to kind of push forward. So we want to introduce a CRD that's going to be representing the pod network in the cluster, and then leverage DRA to provide the name sameness. And I'm going to show you that in a few seconds. Basically, pod network is created by the cluster administrator that represents a network that you want to have in a cluster, right? And then it comes with two fields that basically are the driver specific, right? Whatever the driver defines, that's what they are. The object itself is very simple. It has just like two basic fields, but then the rest is all related to the configuration of the driver. And those, like you can see, those are exactly DRA fields. This is the device class name, and then the OPEC config that the implementation can define, and the user can use it to kind of further specify some of their stuff that they want to do, right? So basically, the object is passing some stuff into then the DRA aspect, where then later on in the pod itself, the user just references that network, that object in the pod. So we are leveraging the array here under the hood, and I'm going to show you what does it mean to the name. It's the same name to kind of preserve the name of the pod network. So this is how we would indicate that, oh, I want to attach this pod into a data plane network or the default network, and the default network in this case. So that's kind of the gist of the usage. And then, of course, we want to define and standardize on how the drivers should be kind of defined. And one of the standardization is make sure for all the interfaces you use, provide your status data into the resource claim, right? So this is what we introduced, that was introduced recently to the DRA API. And we would say that your driver at the end, when it adds the interface, should update the resource claim for that interface with the appropriate data in it, right? So that's one of the things that we need to eventually kind of standardize on how to write the array driver for this to kind of work. And what happens under the hood is basically what we are thinking is user creates the pod network, or the kind of interacts with pod network and the pod. So this is where the multi-network kind of shows, or those are the only objects that the users will interact with. And then as you can see on the legend on the right side hand, the middle item, what we want to leverage is the resource claim template. And this is the auto created object under the hood by our controller based on the pod network with a opinionated options set in it, so that we are hiding some of the kind of specific features of the array, but we want to make sure that it's kind of simple from the multi-networking point of view of how to kind of configure your pod network and then leverage in the pod. I think that's kind of the goal of this. We do have an option to kind of reference an existing resource claim template in case some implementations would like to kind of leverage all more the blows and whistles of the array. But I think there will be the two options, the more opinionated one and the more custom one. But I'm here showing only the more opinionated one, which is kind of the highlight of the whole multi-networking. So basically what we would do is we would create, and this is one of the aspects, I think maybe something that we could improve on, what we are thinking is to create the resource claim templates in every namespace. And that's one of the kind of differences a bit here. Our pod network, we want to make it a cluster scoped object, because this is an infra representation in the cluster. We don't want it to be bound to a namespace, but rather to to the whole cluster, right? Because that's what it should. I think we feel that that's the right place for it. And resource claim, on the other hand, is namespace. So what we are thinking is our controller would create the resource claim template in every namespace existing in the cluster, or any new namespace that would show up, right? We would want to kind of have those objects populated and present, so that whenever a pod comes up, they can easily just reference the name, right? So that they created a data plane pod network, then in the pod, they can reference the same data plane pod network, right? So that's kind of the gist from the user side. And then from the driver and implementation sides, with the provider sides, where this is all the boxes on the bottom, right? They would provide the classes, they will handle the resource slice, and then they would provide the whole driver, right? The array kind of mechanism, right, into this. And as you can see, I kind of color coded the parameters that user would pass, or how we would pass it around, right? So basically, we'll get the OP extract from the pod network object, and then whatever the class gets, right? This is the standard the array functionality. Then at the end, the resource claim that will get passed to the driver will have all this data into your driver, and your driver just consumes that according to whatever you defined and designed, right? That's kind of the general idea behind it. I think this is how ends. It's very straight. I think it's very straightforward. So I'm gonna stop. I'm gonna stop sharing. But
Yeah.
questions, please. And
Okay, awesome. A couple of things. Going back to your original CRD, if you go back a couple slides, pod network CRD. So one of the things I'm wondering about, and you know, I don't know what, is it always true that the provider for the pod network will be the same across all nodes? Like, could you have a case where you use you know, VLAN trunking on one node, but another node uses, some sort of IPv LAN or what's a VXLAN, and there's some router in the infrastructure that bridges the two.
I think no, at that point, I would consider those different networks, right? Because for those what you called out, whatever they are, right? They might have different security aspect, isolation aspects. So that's why I want to explicitly know and uniformly define on, okay, I'm connecting to pod network X. I explicitly know what pod network X. Let's say it's a VLAN X, and it's an L2, and all the pods connecting it is that, right? Otherwise, if we pick and
It's an
choose,
L2 network, basically.
what's that?
It's basically an L2 network. A pod network is a layer 2 network. I mean, it doesn't have to be.
It doesn't have to be, but yes, in this case, I want to know what I'm connecting to. What you're saying is, oh, you might get this here or that there, right? I think there is a way where some of the networks could be like this, right? Where under the hood, my network represents something in the infrastructure. How it connects to in each node is up to you, right? And but then I would
I know what
say
I was imagining. Yeah.
but then I would say this should be hidden in the implementation detail, right? On however the driver does that, and then I see what you're saying on that term, but
Right.
I wonder, is that something that could be hidden in the driver and then implementation?
I mean, you'd have to write like an overarching driver that. So my point is that is a pod network. The question, I guess, is fundamentally: is the pod network a logical network, or is it a physical network in the sense of like connectivity? Right? If it's a logical network, then it's about the workload. It's like I, as a workload author, need to connect to internet, right? And the internet network, how that technology, I don't care how that technology is implemented. I care that it has access to internet, or I need to attach to the internal network that we use for operational data, right? And so I'm going to connect to that. The fact that on this node it's plumbed in this way, on that node it's plumbed in a different way, I don't care, because I know I can reach these tools, those tools, whatever it may be.
I think to answer that question is both. It's whatever the driver implementation or provider wants it to be. I think that's where, because what you're saying, we had those discussions back in the days, and basically what we ended up saying that you define what the network is. Is it a representation of just the VLAN? So its pod network will just be a VLAN, or it's an abstraction, a logical thing, which means, as you said, it's an access to internet, right? And you deal with whatever it is under the hood. And I don't want to constrain folks to say, oh, it's only infrastructure view and it's only VLAN and what's not, and it has to be consistent. I don't want to do that, because I think this should be abstracted enough that you can define what in your driver. I think the driver will then define what it is, right? Is it just straightforward VLANs, or is it just a logical? I'm not sure whether.
When the driver defines it, it becomes difficult to make it pluggable across different underlying, like the driver has to provide the pluggability.
Yeah.
Whereas DRA effectively already has a mechanism for that. For example, if we had one more concept in here, of like, okay, you have a device class, you have a pod network, and that pod network can, access to that pod network can be provided by different device classes. So rather than putting a specific device class with a specific, basically make this a list. And then if they use one of those list of device of providers and device classes or something, and then if they use any one of those device classes, I guess.
Oh, I see what you're saying. So I can list. So device class would be the kind of list of those abstract, whether.
Yeah, or you have you have one more CRD that's like pod network connection or something, and there's like one more abstraction layer. It's up to your use cases. You could probably always add that, but like it's something that I wonder about.
So one point what I did mention is it's I am trying to make it an opinionated way on how this can be used, the DRA kind of, right? So I think this is what you are saying, that we are hiding some of the mechanism of DRAs, but I think that's where it's not GPUs. We are not trying to combine GPUs and NICs, for example, right? I think that's the most use cases are. We are trying to kind of hit the kind of multi-networking where I want to have a representation, a logical, or basically I want to have a network infrastructure object network, which combines, which says, okay, my pod is connected to this, and then I can, let's say, put a service on top of it, right? Because then I need to.
I guess my main point is like, I don't know that the pod network CRD, without it being a logical network, is significantly different than just the user creating, than just creating the device classes themselves, putting this into, I guess, yeah, maybe let me see, what would the device class opaque parameters look like, right? Like, are they different? Are they, like, do you could create a device class that attaches to specific networks directly, and then people could just use a resource claim template rather than it would be a little more work. You wouldn't have your controller that automatically creates it then. Whereas I think if you made this a logical construct, then it has really meaningful like semantic difference to the user, right? Like, oh, I attached to that logical network. And you could still use it as physical networks if you wanted to, but like with a little bit more, with just a tiny bit more, I think it would become much more useful. I guess that's my main point. I think Jack's had his hand up for a while.
Yeah, sorry, Jack. Yeah, go ahead.
Oh, that's totally fine. It strikes me that this approach is actually a little similar to NVIDIA's recent approach with compute domain. I see Kevin K isn't on the call. He could probably speak to, he feels the same way, but maybe a meta point, having an opinionated CRD like this represent a sort of domain-specific DRA implementation to aid probably, ergonomics for users and that kind of thing, and also bubble the sort of primary configuration into one place like this. Seems like there's a similar approach that NVIDIA, I don't know, does anybody else see similarities to NVIDIA's GB200 compute domain, which is meant to represent, various flexible IMEX configurations across its DRA surface area, like or on top of its surface area?
Yeah, I agree. It's a similar, right? It's building on top of the APIs with a separate controller to generate your resource claim templates.
Really?
Yes.
I mean, so it's really interesting. The obvious point that occurs to me is maybe we should standardize this pattern in some ways. This like sort of 2 times in the 133 release cycle that someone's doing this exciting work on top of DRA in a similar way. So,
is there a maybe? I hear you, John, on what you said. That's a fair point, right? What if we do want to have it fully logical, and then I wonder you gave me thinking, what if can we not overload the class, the device class, to do that and have all those like list of all the possibilities that you can have? Could I overload the class doing all those? Because there is the class has lists, right?
You might be able to, yes, actually. If you have the device class contains multiple configs.
Yeah.
Device class, I don't think is explicitly tied to a driver because I think I've used it outside of that context. So you could, the thing is that configs, how would that work? So the driver.
Yeah. If you go to look here, right? Because from my understanding, unless I'm wrong, right? So this guy ends up being here, and then whatever the class below here has, right? It goes to the status of the resource claim, right? Isn't that correct?
So there's 2 things. So you can attach the device class can attach config, and the device class can specify selection criteria. So if you did it in the device class level, how would you know when you matched to? So let's say we might need to take this offline. We might take too long here. I think that we should try that. That's a possibility. The device class would basically be expressing itself as, here are all the different ways you could attach. And then it would get scheduled to a node, and that node would have only one way to attach, right? It would have one specific
Right. I
time
see. Okay. Yeah.
on it.
Mhm.
And then yes, so I think that would work, but we should verify the details of it before we
That's
make
a fair point.
record.
So I have another question to this. Is there something better we could do? Because, as I mentioned, I would create the resource claim, considering this is a cluster scope. I would create those guys in every namespace. And then, I have to handle the whole name collisioning and what's not. So I would just make the until all the names are not the specific name is not used on all the namespace. This is the only case I would allow you to create and have the pod network ready, right? Until then, sorry, man, create a new name, get a name doesn't collide with anything else, which is.
I guess my question, like, do you really want every name? Like, namespace is basically our only tenancy control. It's our only like boundary of authorization, and
So
I mean,
if you prefer to I think that will be our next stage where we can say, okay, create only in this namespaces. I allow this in only those namespaces. This is something that then I can filter out, because if I create in every namespace, I can create a selector, a namespace selector saying only in this namespace. That's it, right? With this label, right? So that's something that we would kind of improve on, and definitely right now just gonna keep it simple, right? Just create. I'm not sure whether that's keep it simple, but right now that's kind of to limit the number of fields and kind of the kind of explanation. But I wonder whether in this all namespaces cases, there's something else that could be done to kind of remedy, instead of me creating those objects in every namespace. Is there some alternative that you can think of that to do it better? Any changes we could do for GRA?
In the previous discussion, if you go back and look at your pod network CRD, if what you're saying is that if we think we can implement all of the config in the device class, then I don't think there's anything left in this CRD. And so instead of having a CRD, you'd have a cluster scope device class called data plane pod network. And then, except enabled, right? That's the thing you don't like. So then.
So keep in mind, maybe on that note, keep in mind that we are just talking about connectivity right now, right? In front of this whole thing, there's a set of requirements like I want to support serviceability. So then what we are thinking long term is I can reference something, because I think I need a handle. I think that's the core thing of ours is we need a handle. I know right now functionality wise the spec is very empty, and I agree with you. It's maybe then we can get rid of it, but we still need a handle, because then I want to kind of reference a pod references this, and then later on maybe we're currently looking at gateway API. Can gateway API reference something to say I want to create a gateway on a specific network? That's kind of where we get heading at with this, right? Or in the future,
if you've got the standardized place to read the service information, you can do services, and it's awesome. Yeah.
So that's the kind of I see what you're saying in terms of spec. It doesn't have much, but basically the handle itself is even if it's empty, right? The handle itself is the key for us to kind of then interop with other kind of features of Kubernetes, right? To say, okay, I want to apply network policy for this workload, but only on network X, right? So there is that. So then basically I say only on
you
that.
Need a name. It's that logical name thing again. Yeah. And so, okay. So, yeah, I think that I don't think you can do anything better than what you're proposing unless you, because resource claim templates are namespace scoped intentionally because of the permissions aspects, right? And resource claims are namespaced. We don't have a cluster scoped object like a resource claim template. The closest we have is device class. So basically your options are stuff everything in device class, and then users manually create resource claim templates and point to those device classes, or what you're doing, which is publish it everywhere. I would probably, if you don't put I would put a namespace. I think Rita had a comment. Rita, so what Rita's doing in the admin access thing is kind of similar in the sense of like admin access is a field in the resource claim device request, and it allows you to request things with certain elevated privileges, really without accounting. And it's done via namespace labels. So like basically you label a namespace a certain way, and it you know, won't allow you to create those resource claims or resource claim templates and namespaces without those labels. I mean, I would probably put a namespace label on here to start, but that's just me. But it's a CRD, it's not a built-in, like with the built-in types, we have like all kinds of, it's very hard to change later. So we
Yeah,
try
exactly.
so yeah, I think that's your best option from what I can see. I don't see a better option than auto creating those in every namespace that's allowed, that's matches your
Right.
selector, which if you have no selector means everything. So
I think one thing I'm taking out of this, that the security concern, permissions concern should be kind of addressed probably right away. I was thinking of iterating that further after, but I think that's one of the aspects that probably should address right away as well.
Yeah, so from a permissions level, you have adding labels to a namespace is a pretty privileged operation. So it's a pretty good boundary. It's not necessarily the right role, right? Like it's not necessarily the right role of granting access to a network. So if you need like really precise, what we did with admin access really, right? We're kind of conflating, we're forcing, if we do it through namespace edit, namespace labeling, we're kind of forcing everybody who can namespace label to be the same level.
Yeah, exactly. One power to other. Yeah, I see. Yeah, exactly.
Unless you put in policies, right, somehow to control what the label names are. So, but nonetheless, you could do, you basically, it's that, or you could create a validating admission policy.
Right.
No, you can't. I don't think you can reference multiple objects. I was going to say, theoretically, you could create a VAP that says if there's a pod network with this name, then only the controller can create that resource claim template with that name. But I don't think you can do that in a VAP.
No, I wouldn't want to do that.
Yeah. Okay. So anyway, those are some thoughts.
Okay.
Yeah.
Any other questions? If not, then thank you everyone for your time.
Awesome. Thank you, Macha. Okay, I think Laura is next.
Yeah. I'll take some screen sharing if you got it.
Yep. All right, you should be able to do it now.
Yeah, I got it. Okay, hi everyone. I wanted to follow up from last time. We talked about kubelet plugin reliability, the pieces that are floating around related to that, and trying to make regular and transparent progress as we proceed towards GA. So I made kind of like a home base, this doc and also this project board. This doc has a couple things in it, some of which I want to just highlight today. But this doc also has a link to that project board. The project board is a view that's in the existing dynamic resource allocation tabs. And basically I just added a board specific like property area to like attach this reliability metadata to it so it can get rolled up in here. So this is how I'm going to try and keep track of what's going on and where it's at specific to this effort. So if there's something that you think needs to be tagged like that, or send it, you can just send it along to me, or you can add that tag to it so that it will show up more easily here. In this doc, besides other stuff that we talked about more generally last time, I did try to surface and pull up this principles section, which is kind of a like conglomerate of things that we talked about last time that seemed to be important for this community that helped kind of guide what I think we'll be doing in the future. Some of this, let me make it a little bit bigger. Some of this like might feel really obvious, but I wanted to make sure that we were all on the same page, but especially as we kind of like come from this environment, which is really focused on like the components that are specific to DRA, and then like go to the SIG node environment where it's about how those components or like kubelet might be used more broadly in other situations. So I'll just briefly go over these here, and I feel like I'm probably going to be repeating myself about this over and over for a lot of the time. But I really took away from last time, we want all expected errors to be recoverable without needing to ask a user to SSH into the node to do some manual intervention. That's like really important to us. That in any of these given situations that we've been talking about, if we can find a way to recover the DRA plugin, if we feel that something is in the way of the recoverability of the DRA plugin, that's really our first line of defense, so that it can continue to work effectively. But we know that there will be transient failures and permanent failures of these DRA plugins, some of which we might or might not be able to recover. For different types of transient failures, I want to sort of open the negotiations in the coming weeks of like what exactly we're prioritizing in terms of time or the expense of like we're repeatedly starting a pod sandbox, or we're repeatedly like trying to pull this image, or we're repeatedly doing this, that, or the other expense. I think people have some like latent thoughts about which of those are like more expensive or more appropriate, but I'll be leaning on the community to help me decide what those are, or throw numbers in your face and then you can tell me no to some of those. And then in the case where the DRA plugin is really permanent, the principle that I'm operating under is that we want to avoid that the workload is invisibly orphaned, like it's stuck trying to like repeatedly restart itself on this node, and it's not transparent to the end user that the reason it can't do that is because the DRA plugin is bad, or like something didn't like will never be able to actually be allocated because of some race condition or other like situation that it got into where the pod has been attached to that node, but that is no longer like a valid node.
That we have a way to communicate back upward that
Yeah.
it's a complete failure. And I think that this one might be, we might be limited by the overall Kubernetes system and how much we can do.
Sure.
Like we don't automatically reap and reschedule failed pods, as I understand it, but
Yeah.
At least we need to get to the state of failed that it can be seen as failed, not that they think it might reconcile at some point.
Right. Yeah, and so kind of relatedly, that end user troubleshooting is like part of this, even though we are attempting to recover things as best as we can automatically. And then we also talked last time, we're focusing on DRA, even though we know that some of these improvements may help with other things in the plugin ecosystem. So just wanted to make sure that was on everybody's radar. I'll probably be repeating some of these things or referring back to them as we make decisions going forward. I took a bit of,
Before you get into the next thing, Jack has a
Yeah.
hand.
oh, sorry, I didn't see that.
Hey,
Go
Laura,
ahead.
do
Hey.
we want to bake any language in here about the driver ecosystem? Because there's a lot that the driver, the installed driver can do to help or hinder these principles. I'm thinking in particular of things like driver upgrades. Like we need to make sure that if you're creating a DRA driver as you upgrade, it's completely graceful. As you upgrade Kubernetes on top of the driver installation, it's graceful. Those types of non-dealt with scenarios can pretty easily brick a node, and so it's.
I think what you're saying is basically we have to operationalize these principles. Use a well, we can do it through changes to kubelet, through changes to but also through changes to the DRA drivers themselves, and therefore to our framework and example driver as to how these things are done and our best practices or whatever that we publish.
Yeah, that
Yeah,
all
which-
sounds good. Like there's a certain amount of enforcement that we have over the kubelet surface area to
Yeah.
optimize for operable, but we're in a cooperative relationship with the vendors and their driver implementations, and so we can't,
Yeah.
we can't users can't succeed without both of those aspects working together. So yeah, maybe we can matriculate some best practices into the example driver project, and or we can during the 134 release cycle, maybe we can reach out to the key vendors that are going to be shipping production drivers and exert some chop wood carry water muscle to see the stability across the defined sort of operational expectations that we bake into here. Something like that.
Okay, I'm hearing two kinds of things. So
I think the key is to operationally these principles is that it can be done in kubelet and in the drivers, and it's a split responsibility, right?
Yeah.
And we can try and help the driver vendors and authors as much as possible, but it is a split responsibility. So we should do what we can to help them.
yeah. Okay, and then there was a separate concern about all of these properties between a driver upgrade and a driver upgrade simultaneous or otherwise.
I think
Around
what I
Kubernetes
was
upgrade.
expressing, you've actually captured there. So
Okay,
at a high level, solve for Kubernetes upgrades, solve for driver upgrades.
okay, I see. Abhishek has a hand too. What's up?
Hey, hi, this is great. By the way, I don't know if the last bullet covers that, but in our previous meetings, we discovered that there were, classic Kubernetes issues like that we are not solving. So
Yeah.
maybe add a bullet point or list of things that we are not solving. One of the things that John mentioned in this call is not sending pod back to the scheduler. So all those
Yeah.
things, yeah, that would be
Right.
great. Yeah, thank you.
Okay.
Yeah. good
Yeah, be
point.
more clear about what we're not doing.
Mm-hmm. Yep. Thank you so much. This is great.
Totally.
I think you could add that bullet back about. I think it was a good point that
Okay.
I don't know if it's a principle, but it's in scope
All right.
to address how they behave across upgrades, both of Kubernetes and drivers. So like the seamless driver upgrade that Patrick has been working on, right? That's definitely in the scope of this, right? But what happens during a Kubernetes upgrade to drivers, that's something we've talked a lot about in the context of API evolution, and building a little bit of a library so that the driver can detect what feature gates are enabled. Like that kind of falls into that reliability scope too.
Okay, cool. So I'm putting these here for now. I just kind of also want to integrate this with there's kind of like a first like level that I want to like get to and focus on, which is about like the kubelet failure modes. Some of these are pulled from the prior conversations that Sergey has opened. Yeah, I'm just going to try and figure out if these things like kind of belong to sort of like an in-scope list, or belong in like a specific milestone is what the trigger is of this. But I hear that that is part of the reliability story. Okay, any other comments or like, oh my God, we didn't put in my super important principle of stuff. Okay. So FYI, this is kind of what I'm operating under as like I'm making like any priority decisions or figuring out like what to like surface or escalate. Stuff that is going on right now that had been discussed, like brought up to me last time, is both in this project board, and then I have lifted them up here right now for the purposes of like our conversation today, and like while I was getting myself up to date on what was going on. as I understand it, for the, sorry, I'm going to scroll back down, but this subset here of this milestones, which I would love to have some conversations about at KubeCon EU, and maybe a little bit now, but maybe more then and in coming weeks, is about these failure modes that had been surfaced that are kind of specific to the relationship with Kubelet, including when the plugin is initialized, what things should happen in what order. If the kubelet does restart, like how do we find the DRA plugin or the framework that we have provided impacts the reliability of both itself and any other plugins that are going on in kubelet itself. If DRA crashes, then if it's a infra crash or if it's something that like we can re-register, how fast can we detect it? How fast can we recover? If it's a logic fail and we're going to be stuck here and like we can't get back, this is back more in that permanent failures, like what do we think is a good idea to like keep retrying, and do we ever give up, like from Kubelet's perspective? So this is very much at like the plugin level of the work that's going on right now. Aspects of this in particular, like the plugin being crashed and restarted and the detection time and reconnection, is being directly addressed by this connection monitor pull request. And for the seamless driver upgrades, that's kind of like, it's not specifically addressing any of these like times or like questions in the aggregate, but it's more about that transition between those two versions.
I think it's also covered, maybe it wasn't covered in this the docs from Sergey, but it's covered in your principle.
Right. Yeah. So I'm still tracking it, but like in terms of like it covering something that's in kind of my first like pass of like, I think these are like the most, I don't know about most important of everything, but this is the stuff that's like, we need like kubelet. If we make some decisions about it, we likely need some like kubelet core changes to like address or like figure out how that like any of those timeouts, or if like the plugin watcher needs to make some changes. So that's what I'm kind of trying to prioritize.
So I think probably what we need to do is take these different things and make issues for them and then put them on your board and we can execute through them.
Yeah. So anyway, so this is the heads up of this is like what I'm focusing on the most for the reasons of that. I think it still aligns with the principles that we discussed about last time, and I think that they have a probability of touching the like core kubelet code, and that some of it at least is already in progress. I'm going to continue to cross-reference those with anything that anybody sends me that might be in progress right now, and then just start making new issues that encapsulate what I know about those things so that we can track them independently. And then this doc, I guess my most important thing is this doc is like my home base. I'm going to keep this up to date with what's going on. And then this board is the secondary location for organizational purposes. And that's what I wanted to say. Thanks.
Awesome. Thank you, Laura. Awesome. Okay. Last item is more a call to for awareness. Let me just put that up. We have a bunch of things coming up. For those of you who will be at KubeCon EU, I hope I'll see lots of you there. We have unconference topics for the first day. That's for Monday. These are all throughout the week. And I think I got all of them here. I went through the schedule when it first came out. So I don't know how accurate it is, but hopefully it's pretty accurate. And if you have a talk that's related to DRA and I didn't put it on here, or to device management in general, please just go ahead and add it. But I just wanted to point everything out here for everybody. So any other questions, or we can get 12 minutes back? Okay, I guess maybe one last point is it is code freeze in 2 days. So if you want to review things where partitionable devices is on the edge here, we're working hard to get it in. We had to push out mix-ins, which is a important but not functionally material. It's like a more of an efficiency thing. So we had to push that out. I'm sorry, I can't read your whole, I have to go what your comment is there, Rita. The maintainer summit ones are unconference. So what that means is that well, there might be, yeah, there might be a maintainer summit one up here somewhere. I don't know. But the unconferences will be picked like the day of or something by the organizing committee there. So based on what gets upvoted. And there's only like 5 slots for not just for Kubernetes, for all of CNCF. So I don't know what's going to happen. Okay. Anyway, code reviews, please jump in there, give some code reviews. We're trying to close on the device taints. We're trying to close on partitionable. And I don't know, Rita, has admin access merged? I thought getting a lot of reviews, but I don't know that it's merged yet either. So we're trying to close on that. And there might be some other specific issues if anybody wants to raise them, but please, yeah, let's try and get that done. We don't have much time left. And that's it. So unless there's any other comments, thank you, everybody. And we'll see you in 2 weeks. This is canceled because many of us will be at KubeCon. Maybe some of you will be at the one next week. That's in the middle of the night for me. But anyway, I hope you all have a great couple of weeks, and hopefully I'll see a bunch of you. Bye-bye.
Thanks.